This is a Triple J podcast.
Hello, welcome back to the Science with Dr. Karl podcast. My name is Lucy Smith, and this week we get into some things that you may have noticed before. You know, if you've ever looked at frozen milk, it's kind of got this yellowy tinge. Someone asked Dr. Karl why that is, and he's going to tell us a story about visiting an ice cream factory. Incredible. Let's jump in. Dr. Karl, how are you this week?
Ever so peachy keen.
Have you learnt anything this week? Because this segment is not only about you answering science questions, but also finding out what you've learnt week to week.
Surprisingly, it turns out that the sacred brown drink that used to be based on cocaine in the past, it's called a cola, but now it's just brown with sugar, but you can get the diet version, can be used to treat hairballs in the stomach.
What?
So you get various things building up. Okay, stomach. There's the stomach, the small intestine, the large intestine. We're talking about the stomach. And so this woman turned up to casualty with this pain, abdominal pain, a bit of vomiting, just lots of pain, been going on for weeks and weeks, did an MRI scan and found that she had a bezoar, B-E-Z-O-A-R, in her stomach. And these are typically from cats. They have a hairball, they lick their own fur, and then they'll clog their tummy, then they vomit it up. And you find them sometimes in humans, and in the old days in medieval Europe, when people were worried about being poisoned by somebody else, they would have a bezoar from an animal set into a ring on their hand, and then they dip it into the drink that they suspected of being poisoned, and it would supposedly purify it. Of course, it didn't.
Oh.
So there's different types of bezoars. There's hairball bezoars. There's lactobezoars in little babies where the milk coagulates. There's some based on the fruit persimmon, which is incredibly rich in tannins in the skin. Mm-hmm. And when it meets up with the acid in the stomach, gets the indigestible fibre in the persimmon and turns it into a persimmon ball. And she had one based on just normal food that she was eating, vegetable matter that should have passed into her large intestine and been broken down. But she was on the Ozempic semaglutide, which reduces weight by many ways. And one of them is that it slows down the emptying of the stomach. So she went from 100 kilos down to 80 kilos, but the gastric emptying had slowed so much she had this terrible big ball. And in the old days, having diagnosed it, they would have gone, okay, swallow the black snake and we'll have a little knife on the end of it and it'll chop the ball, maybe the size of a tennis ball.
What?
Into little pieces. But a study in China discovered with 162 people that the sacred brown drink, which in a typical tin has something like 15 spoonfuls of sugar. It also got phosphoric acid and another acid, and they found it could actually eat the bezoar. So they put her on 1.5, they tried to put her on 3 litres of the cola drink. She couldn't have it. They gave her 1.5 litres, and the next day she could feel a sort of like a little tugging feeling inside her stomach, and then the pain went away, and when they did the next scan, it had all gone.
Oh, my God.
So besides removing rust off coins, the sacred brown drink can also, in some cases, fix a bezoar, which is very uncommon. Don't drink it because you're trying to think you're going to stop getting a bezoar. No.
And I think I've told you this. My friend used to work in events, and sometimes when they were in stadiums and they needed to clean the rust off of the seats, they would use cola.
Yeah, and they talk about coking the floor on stage.
Oh, yes.
So they pour with a sugary drink across the floor and it makes it sticky so nobody's going to slip when they're doing fast-moving dance routines.
Oh, my gosh. All right. Well, we've learnt something new already. But if you've got a question, now is the time to send it in on 0439 757 555. Chris in Terrigal is kicking us off. Dr. Chris, what do you want to know?
Hi, Dr. Karl. It's Chris speaking. I want to know how nighttime solar works.
In general, you don't make much energy from solar at night. You get a little tiny bit. Now, I'm a little bit confused here because on one case, I've just gone looking in Wikipedia, etc., and it's saying that the solar panels today convert the visible light into electricity. And yet, working with somebody at the University of Sydney, they said that they turn the heat into electricity, so I'm confused. I'm going to have to chase it up. So
I'm confused too.
Yeah, I am. So the thing is, you can get an incredibly small amount of energy at night. You can get some energy from your solar panels at night, but bugger all. Basically, you're counting on getting the energy in the daytime and then storing it in batteries. Is that kind of what you're asking, Chris?
Oh, it was a diode used in infrared goggles that they were using to create infrared to generate power from infrared light and the background radiation of the space.
Yeah, look, I'm confused. I'll have to check with my colleague Anita Ho-Bailey, who is coming out with research that might double the amount of electricity you get from solar panels. I'm confused in my head. I thought I knew it. I don't. I'll give you some homework next week. Next question, please.
You need to talk to Anita, yeah.
I need to talk to Anita. She rocks.
Thanks, Chris.
Thank you, Dr. Chris.
That's okay.
Thank you.
We've got Josh in the Hunter Valley. Josh, you got a question about space.
Hey, doctors. Yeah, my question is, why does light travel in space but not sound?
It's kind of confusing. The way that sound works is that one molecule hits another, hits another, hits another. The energy is transferred from molecule to molecule.
Right.
So imagine you've got a bunch of people standing close to each other in a long line or queue at a bus stop, and you sneakily push over the last person who falls forward onto the next person, and they stop themselves by falling by pushing on that person. They're then vertical, but the next person falls over, and so the line of falling over of people travels down the line. And that's what happens with sound travelling through air. One molecule hits another, hits another, hits another, and the energy is transferred.
Right.
Sound does happen in space. You do have some parts of space that are not a perfect vacuum, but rather are what we call stellar nurseries, where stars are born, and there the density of matter, instead of being, I'll pick a number, say 1 hydrogen atom per cubic millimetre, is millions. And so when a star goes supernova nearby, it can put a sound wave through space. You can actually have a sound wave through space. You can't hear it with human ears, but it counts as a sound wave because the energy is being transferred from one molecule to the other. With regard to light, electromagnetic radiation, the best explanation I've been to get is that it bootstraps itself, which doesn't answer the question. Bootstraps, in the old days, they used to make jokes about how if you wanted to levitate, you just reach down, grab the boot straps or the boot handles or the boot laces and pull yourself upwards. And from that, we've got the term a computer boots up. You know, it starts from not being alive to being kind of alive. And so you get these two waves at right angles to each other, and they will propagate through empty space. You don't need any atoms at all. And you've got the electric wave going left, right, propagating through space, and then the magnetic wave going up, down, and they propagate through space. It's called bootstrapping. I think we have to stop there because I'm running out of knowledge, because I got confused when the clever people in physics told me about it anyway.
That's unreal. Amazing.
Thanks, Josh.
Thank you, Dr. Josh.
Hey, Jason, we're going to stay in space with your question. What do you want to know?
Hey, doctors. Thanks for taking my question. I was just wondering, when you're looking at a picture of the solar system, the planets are all shown like they're on a flat plane, like a record, so that they follow their plane on that flat plane. And I was wondering, do they actually rotate on a flat plane, or are they sort of a little bit more on their own plane, similar to if you saw a picture of an atom?
They're kind of lined up with the equator of the sun, kind of. The whole planetary science thing is in a bit of chaos at the moment. We've found about 6,000 planets out there. And the weird thing is that the two most common planets, a hot Jupiter and a super Earth, do not exist in our solar system. A hot Jupiter, that's something the size of Jupiter, but instead of being so far out, it takes 10 years to do an orbit. Mate, it's so close, it takes 4 days. Mercury takes about 70 days. And that's really common. And another one is a thing called a super Earth, which is about 5 times the size of or 5 times the mass of our Earth, and we haven't got one of those either. And we think that what happened in our particular case is that in the early days, due to various physics, there was super Earth and Jupiter and Saturn. As you would expect from the physics, it's called the tack theory, T-A-C-K, like a ship tacking at sea to travel against the wind, right? And so Jupiter gets dragged in by various forces, breaks up all of with its gravity, runs the super Earths into each other. They then turn into rubble, and normally they then vanish and the Jupiter's left behind. But in this case, there was Saturn, and so Jupiter towed Saturn in, and then Saturn towed Jupiter back out, which is what we've got today. But why the planets are in the same orbit is because of the stellar nursery. So in the stellar nursery, you've got all these atoms of hydrogen around, and sometimes even molecules and dust. A supernova explodes, and some of the atoms come closer together. Because they've hit each other, they're heavier, they've got more gravity, and they start attracting other things towards them. When you get enough hydrogen atoms together to equal 70 times the mass of Jupiter, that's the magic number, then the stuff at the middle gets very hot, 15 million degrees, and it ignites. You've got solar fusion, a nuclear fusion happening, and then suddenly it ignites. Now, it starts to, then it's also rotating. Stuff is always falling in, and stuff is always falling in a bit more on one side than the other, and so it'll rotate either this way or that. And as it rotates, it drags around this big cloud of gas and dust, and the circular cloud flattens out into a disk roughly lined up with the equator. That's the answer to your question. It's roughly
perfect.
lined up with the equator, but we have found 2 solar systems where we've got planets going over the North Pole. They're going at right angles to the equator at the start. Yeah, okay, we don't know what's going on, right? Lot to learn. If you want to get a good job in physics, go into planetary science.
Awesome. Thank you so much.
Hamish in Wagga Wagga, what's your question?
Hey, doctors, how's it going?
Pretty good.
I was wondering if a sheep and a goat can crossbreed and create a geep.
It's a nice name. The problem is that they've got different numbers of chromosomes.
Yeah, okay.
I don't know what the numbers are. So humans and Neanderthals could crossbreed. They died out about 40,000 years ago. We don't know why. And everybody outside of Africa have about 2% of their DNA, Neanderthal DNA. Also, the Denisovans, they could crossbreed with us. They died at a similar age. I forget the exact number. But they've got, with regard to the sheep and the goat, they've got different numbers of chromosomes, so you can't do it.
Yeah, right, yeah.
But we could sort of fool around with it. We're kind of working on a technique where you can have, for example, people giving birth to a baby via surrogate without actually having sex. It's a complicated thing. So you could have a baby containing the DNA of both the parents if they were both male or both female. And it's a really complicated thing. There's a really good article on ABC Science about it. So theoretically, further down the line, 2 males could have a baby that had their DNA, or 2 females. Look up the ABC article. It's complicated. Too long for this program.
Yeah, fair enough, mate. Cheers.
Thank
Hamish,
you.
why a geep and not a shoat?
Oh, good point. Yes, why?
Yeah, no, I don't know. It just sounds better, I guess.
Yeah, I do like geep.
Yeah.
Thanks, Hamish.
Thank you, Dr. Hamish.
We've got Eliza in Parks. Dr.
Eliza, welcome.
Talk to us. So you live on the edge of town?
I do. I live about 10 kilometres from our local airport, and there's only like farmland between me and the airport. And I noticed all winter, especially on foggy mornings, I could hear the planes turning on in the morning and warming up. But now that the weather's warmed up, I can't hear them anymore. So I'm wondering, does sound travel further in cold, wet air than dry, hot air?
It gets trapped. So if you're just looking at plain, flat air with no layering, and you emit sound on the ground, it'll travel in all directions, up into the sky, horizontally, left, right, backwards, forwards, north, south, east, west. If you have colder temperatures, you can have layering, you can have temperature inversions, and the sound can be trapped. Okay, a little diversion. So down at the ocean floor, the temperature's around 3 degrees C because that's where water has its greatest density. Not at 0, but at 3. And the humpback whales and other whales go down and then they emit their sound in that layer, and an hour or two later, or say 6 hours later, it goes from one side of the Pacific to the other at the speed of sound, and it's trapped in that thin layer. It doesn't diffuse through the whole ocean. And so the humpback whales can dive down and hear a song from another humpback whale. Getting back to your case, so you've got layers in the air of different density, and the sound, instead of going in all directions, only stays trapped in that thin layer, has greater loudness, can be picked up at a greater distance. In these layers, the temperature inversions, etc., don't happen so much in summer. So does that kind of help-ish?
Yeah, I think so.
Yeah, so it's the layers. The air is layering and the sound is trapped rather than going in all directions. It's trapped in a layer. And so you can hear it because you're in that layer down at ground level.
Oh, perfect. Thank you.
Great. Thanks, Eliza. And Lou in Silverdale. Lou, you have a question about motion sickness. What's going on?
Hey, doctors, great to be on the station. Yes, I've got pretty bad motion sickness. I have probably in the last 20 years. I started off being able to be a passenger in a car, and then gradually as I got older and older, I get worse. I can drive a car with no problem, and then I race cars, and I actually have to take a pill for motion sickness because I was getting sick when I was driving. So I take this little yellow pill, and it makes me perfectly fine. And I've had every test you can think of. Yeah, it's am I allowed to say what it is?
It's a pharmaceutical name, I guess.
It's called Dramamine. I get it from America.
Is that the same as on Danzatron?
I'm not. I've had on Danzatron as well, but I'm not exactly sure. But so I take this little pill. Anything, I can go on a plane, I can go on a cruise, I can do whatever. I feel perfectly fine. But this little pill saves my day. But they don't seem to be able to solve the problem permanently, or they've got no idea how it happens.
Wow. We do live in a very different world from the one that we evolved in, because in the world that we evolved in for 200,000 years ago to about 15,000 years ago, the human didn't ever experience external acceleration unless you fell over.
Okay, yeah.
Or rode a horse.
Yep.
And then we start experiencing external acceleration. Yep. You feel balance, and this is tied to motion sickness, in your something inside the ear called the vestibular system, but also by this thing called proprioception, where you know where your body parts are. And it's more complicated than just a mismatch. It goes to a deeper level.
Yeah. It seems to be for me, it's a combined thing, because if I sit on a simulator that's not moving at all, I'll get sick. If I'm looking at a screen, watching something like that, I'll get sick straight away, and I'm not moving at all. So it's a strange thing.
It's poorly understood. It's not just me not knowing about it, but it is actually poorly understood. We don't understand why something as simple as sitting on a chair, you don't get motion sickness, but sitting on a chair looking at a screen, you do, even though neither of you are moving, and we can't explain that. But the good thing is you've found a medication that'll fix that, providing you remember that all drugs are poisons, what matters is the doses, and then make sure that your doctor knows about it and looks for interactions between that and whatever else you're taking.
Absolutely. I always check, because I do have to take other things. Just on that other thing about sound and motion and hearing things from the previous caller, I have a shooting range that's due south, and when there's a southerly, I can hear the guns going off, and if there isn't a southerly, we don't hear a thing. So definitely air motion makes a difference to the way sound travels.
It'll carry the sound with it, but also it's trapping the sound energy in a thinner layer close to the ground rather than letting it radiate upwards, because the stuff that's going upwards, you lose that energy, you don't hear it. But if that energy is trapped into a thin layer near the ground, suddenly the amount of energy you've got is a lot more.
Thanks, Salud. We got Marcus on the Central Coast. Marcus, what's your question?
Hey, doctors. The question was, we were recently, it's the speed of how fast does the Earth actually turn?
At the equator, it's 1,600 kilometres an hour, and at the pole, it's 0, and in between, it's kind of in between, following a sort of a sine relationship.
Right, because we were fortunate enough to go on a family holiday to Fiji, and when we flew back, we were flying in a westerly direction, and I thought we'd be able to see the sunset out the window for a bit longer than we did.
So at the equator, the sunset is the shortest, and in literature, people have poetically said that the sunset fell like a cannon. Like bang, that was it, the sunset happened. And at the other extreme, down near the poles, the sunset can take a really long time. There's a weird phenomenon called the green flash, which I've been lucky enough to see twice in my life. So what you do is, as the sun sets over somewhere very flat, like the ocean or a desert, you just sort of wait for the sun to go down. And every now and then, in my case twice in my life, I've seen a green flash, and it lasts for a fraction of a second. But people at the South Pole, literally the South Pole, have seen it hang in the air for 20 minutes.
Wow.
So the thing to remember is that the equator The sunset is very short, and it gets longer and longer as you get towards the poles.
Yeah, I just thought because we were travelling in a plane that was motoring along quite well, like they're doing hundreds of kilometres an hour, I thought it would last longer.
And you're actually chasing the sunset, so it would last longer.
Yeah.
If you're travelling in a Concorde, which used to fly at around 2,200 kilometres an hour, that's significantly faster than the 1,600 kilometres an hour, you can throttle the speed back so you can chase the sunset and have the sunset for as long as you want. In the case of the Concorde, it was used on at least one occasion to chase an eclipse. So as the shadow of the eclipse went across the Earth, instead of just lasting for a minute or so up to a maximum of about 7 minutes, I think they managed to get half an hour out of it by chasing it. Wow. So you should have flown a faster plane and then it would have happened, but there are no supersonic jets at the moment for passengers. There might be in the future.
Great. Thank you very much.
Great. Thanks,
you.
Marcus. Grant in Port Stephens. Dr. Grant, what's your question?
Good morning, doctors. How are we today?
Peachy keen, Dr. Grant?
I was wondering if there was any kind of update on the 3I Atlas comet that's heading towards Earth and supposed to be passing around early November.
That's right. So around November, December, it will reach its point of closest approach. And I've read online that it will crash into the Earth. In fact, it's going to miss us by 250 million kilometres, which is not quite the same as crashing into us, but people can write anything. It's called 3 because it's the third one we've seen of interstellar eye. It's the third object from deep space that has come into our solar system, and it's called Atlas because that's the name of the consortium of telescopes that found it. It has been claimed by somebody called Avi Loeb, L-O-E-B, at Harvard University, who is a genuine professor of astronomy, that this is definitely interstellar in origin, and he's kind of wrong. So every time we've had something come through our solar system, a comet on a previous occasion, and then a flat pancake lump of rock, Umama, he claimed that each of them is definitely proof of intelligent life. This time, based on a sample size of 2 objects, a comet and a rock, he said, well, this doesn't fit in with the normal range of things that we've seen, so therefore it's alien. No, we've only seen 2 altogether. This is the third one. And then he said, well, it's really far away and we're not picking up any tail from it like you do from a comet, so therefore it's alien. No, it was too far away. When it got closer, we started to pick up chemicals. And then he said, the chemicals in it are different from comets in our solar system, therefore it's alien. No. We mentioned earlier about stellar nurseries. And so in the case of the stellar nursery from which we came, we have found 2 stars which also came from the same stellar nursery. And we looked at their makeup of the atoms in the stars, and they're very similar to ours. And we're saying, okay, they came from our stellar nursery. So if a star or a comet comes from a different stellar nursery, there's different circumstances, different numbers of elements in that stellar nursery, and so it will have a different makeup. So at the moment, it's behaving just like a comet would from outer space. It is definitely there's nothing to say it's alien. Have you been hearing people saying there's definitely of alien artifact origin?
Yeah, I've definitely heard lots of different things. I think it's quite a leap just to go from comet to interstellar extraterrestrial life. I just thought it was interesting, the comments that people have made that it's not behaving like a particular comet, like the speed that it's travelling, the temperature, and just the chemical makeup, I suppose.
Okay, well, they're dead right with the speed. So if it's in our solar system, it'll be travelling at a much slower speed, but if it's coming from somewhere else, depending on the relative velocity, it can come much faster or slower. In this case, it's going faster. Is it behaving like a comet in terms of speed trapped around our sun? No. Why not? Because it's not trapped around our sun. Therefore, it's moving at a different velocity. That doesn't mean that it's alien. It's just that it's not trapped to our sun. So it's going to skim into our solar system, be bent a little bit on its path by the gravity of the sun and the other planets, depending on how close it gets to each of those, and then take off and never come back again. By never, I mean probably many billions of years, and the universe is only about 13 billion. Nothing to say it's alien yet. I want it to be alien. I really want it to be alien, but it's not. I love science fiction. I want it to be alien.
No, that's fake news, Dr. Karl. It's definitely alien.
Oh, okay. The check's in the mail.
All right. Hey, thanks, Grant.
Thanks, guys.
And we've got John in Lismore here. Dr. John, what is your question?
Hi, doctors. How are you?
Good.
My question's about regenerative hearing. I've been dealing with some hearing loss for a while, and I've sort of been following clinical trials on regrowing the auditory nerve, and I'm wondering if it's possible to regrow the hairs as well.
Yeah, it's a really good question, and we can't do it yet, but we're getting closer. So the chain of energy is that sound energy comes through the air, molecule against molecule. It then goes down the tapered canal of the external ear, and then there's a bit of what they call energy matching, and then the eardrum moves back and forth, and then a bunch of bones move back and forth, and then a pressure wave is set up in a liquid inside your inner ear. And in that inner ear are two sorts of cells called hair cells, inner and outer, and when they bend, they give off electricity. If you have a loud sound, they bend a lot. If you have a very soft sound, they don't bend much. If you have a really loud sound for a long time, they get sheared off, like you got a lawnmower, and they're just chopped. They get damaged, and we've found this in autopsies under microscopes of people who have had severe hearing loss, and we do have the potential to grow new ones. Once upon a time, following the instructions in the DNA, we grew hair cells. We're learning how to do that. We haven't got there yet. We're learning it with what are called stem cells, and there are many different types. And the trouble is that when you're dealing with stem cells, you're also dealing with something that's close to a cancer. So unfortunately, we're not there yet, but it's definitely coming. By the end of this century, we'll definitely be able to regenerate most body parts, but that's no good to you in the next 2 weeks or a year. I'm sorry.
That's right. Thanks, doctors.
Thank you,
John.
Doctor.
And we got Karad from Mackay. Dr. Karad, you got a question about sleep.
Dr. Karad,
Morning,
welcome.
doctors. Hey, morning, doctors. How are you?
Good.
Peachy keen.
I'm just wondering, at what point does the brain switch from being awake to sleep?
There's a bunch of triggers. One is the circadian rhythm, circa meaning in Latin about, diem a day, and it's about 25 hours long, and so there's a bit of tension, so you tend to feel sleepy the same time of day. Then there's temperature regulation, and your temperature tends to drop in the evening, and it tends to get you ready for falling asleep. There's neurotransmitter changes in the brain. Going to sleep is not like turning an engine off on a car where it no longer runs. You might have a little bit of activity in a car, like the clock might go and that sort of stuff. No. The brain keeps working in different parts. So when you're asleep, the memory consolidation areas are just raging away. And you're making growth hormone from the anterior pituitary during the night when you're younger to grow taller, when you're older to do repair. Another thing triggering you off to go to sleep is the environmental cues and also just the exhaustion of the day. If you look at the brain activity via EEG, electroencephalograph, by little electrodes all over the head, you'll see things as you go deeper into sleep called sleep spindles and very characteristic electrical activity, and then you've drifted off and then 15 minutes you're into sleep. So overall, just to finish off, it goes through a 1.5 hour cycle. You're wide awake and you go through sleep stages 1, 2, 3, 4, and in 4 it's really hard to wake you up, and then you come back out again into kind of paralysed. This is the REM sleep, rapid eye movement, where your eyes are flickering left, right, like you're looking at an invisible tennis match on the inside of your eyes. You're doing a lot of dreaming then, and you're paralysed, so you can't act out what you're dreaming, like running away from a dinosaur. So it's a very complicated activity, and even today we don't fully understand it. And the way to annoy a sleep scientist is to say, why do we sleep? And I go, okay, we don't know why. You happy? So does that get you sort of started thinking about it, Karad, or is there something else you want to ask about sleep?
Yeah, definitely. I was just laying in bed last night. It was taking me a while to go to sleep, and I was like, well, at what point do you actually switch from awake to asleep?
Yeah, and you can never actually go back and say, I was asleep again. It is hard sometimes. I find it, in my case, I see occasional patterns of light and I focus on the patterns of fuzzy light and I try to follow them, then I'm gone. Does anything like that work for you, Dr. Karad?
It's really weird, but I just picture blackness and then I fall asleep. That's how I fall asleep really quickly.
I do like a happy ending.
Thanks, Karad.
Thank you, Dr. Karad.
Have a great day.
Dr. Karl is with you answering your science questions. We got Glenn in Sutherland. Glenn, got a question about milk.
Yeah, got a question, doctors, about milk. It's when it's in the bottle and it's not frozen, it's white. and if you put it in the freezer and you pull it out when it's frozen, it's yellow. Why does milk get a yellow tinge when it's frozen?
Well, milk is about 85% water and roughly 12% a mix of, fat, protein and carbohydrate. And it's the fat that's coming out. Normally, you do not have the fat coming out separately in milk because it goes through a process called homogenization. Now, I went to an ice cream factory and they told me that when they homogenize the ice cream mix, it moves at faster than a spacecraft returning to Earth and faster than the International Space Station going around the Earth. And I've got to chase this up. They're saying that to homogenize it, to mix the fat in with the milk, they use big fat engines and they've got these big fat hydraulic rams. You're talking about stainless steel bolts like the length of the diameter across your thumb is long. These are big fat bolts, and then they force the liquid, the fat and the water through a tiny gap, and it's travelling at 11 kilometres a second. The International Space Station only travels at 7. I've got to check whether this is real, but it was very impressive. So what happens is that the milk has been homogenised. In the old days, or if you just get the milk from a dairy, you got the yellow fat on top. So I'm guessing that when you freeze it, it separates out. That the milk, that the fat comes to the outside. And just by the way, you can tell when you're in the Australian outback proper, when you go to buy some milk and you can't buy liquid. You can only buy frozen. Because milk has been pasteurised, which means that it kills most, but not all of the germs. You can't kill all of them. Otherwise, the milk, you go into ultra-high milk, temperature milk, 120 degrees C, doesn't taste nice. So it's got a life of about a week or so. And by the time you get into the real outback, it would already have reached its life and gone off. So milk that's destined for outback servos is frozen. There you are. So I've never noticed that it was yellow, but next time I'm going out, I'll check it out. Anyway, that's the reason. The fat has come out from the liquid emulsion.
Yeah, no worries. Thanks, doctors.
Yeah.
Great.
We've got EJ on the North Shore. Dr. EJ, you were at our live show at the Enmore Theatre.
Yeah, I was.
What was your favourite part?
It was actually so fun, but I think my favourite part might have been all the funny questions and the question about how many tons of bananas in one sitting would kill you.
Mm-hmm, exactly.
3,500 tons.
Yeah, 3,500 tons, exactly. EJ,
Wow.
I love that you remembered that. If you want to know what EJ's talking about, we have our live show up for you in full on Triple J's YouTube channel, Science with Dr. Karl, live at the Enmore Theatre. EJ, you've got a question about time travel. What's up?
So my question is, what would happen to the universe if time travel was possible?
When the universe started up, there were about 12 dimensions.
Mm.
Now, today, we've got the 3 space dimensions, backward, forward, left, right, up, down, and that sort of defines where you are, and then time, which, as we know, our time dimension only goes forward. We've got good grounds for believing that the other 8 dimensions kind of curled up and went away and hid from us. They're still there somewhere, but we can't get to them. And one of them is a time dimension that is not the same as our time dimension. And I can't even imagine what it is. So is it possible to have a universe where you could have time travel? You're talking about time travel backwards, not just forwards like we regularly do, but backward? Yeah? You think? The answer is maybe. How about that as a definite hand-waving maybe? So I'm guessing that by the end of this century, we will have solved the problems of dark matter, dark energy, the missing black holes, and the missing dimensions. And they will be like little toys, and we'll say, hey, Jacinta, stop feeding dark energy into the black hole and come in and have lunch and stop travelling through time backwards.
So what would happen to the universe, though?
It might be one of those things where if you jump into another dimension, I've read science fiction stories on this, that when they jump into another universe, the universe behind them vanishes. And there was one science fiction story where a person had discovered this machine to jump from one of the millions of universes into another one, and then they ran into a mathematician who said, hey, I've just done the mathematics on this, and each time you jump into another universe, the one that you left disintegrates and vanishes, and everybody dies. And they said, okay, see you later. And they jump off, and then everybody vanishes. It was a very short story, only about 2 pages long. So the answer is we don't know, but you can have fun exploring that concept with mathematics, which is just another language like Mandarin or Aranta or Spanish. So the answer is we don't know.
Well, if someone time traveled from Earth
Mm-hmm.
and would the Earth just like everyone on it die?
Well, this is what we don't know. We've got 2 machines for time travelling theoretically. One is a wormhole, and if they exist, they're very stretchy, and you take one end of it and you bolt it into the ground, and the other end you move it close to the speed of light for 1 hour.
Yeah.
So in that 1 hour, it ages 1 second, and then you bring it back to where the other one is, and you go through in one direction, you go forward in time by 1 hour, minus 1 second, and you go the other direction, you go back. That's one mechanism. The other is you get a neutron star, refashion it into something that's 20 kilometres long, 1 kilometre in diameter, rotate it at 1,000 revs per second. The outside is moving at half the speed of light, and if you go into a tight orbit around it, you'll get theoretically brought back to when it was first started spinning. Once again, another theoretical construct that we haven't been able to do with our limited engineering.
Oh, wow.
Oh, wow.
Thanks, EJ.
Thanks, EJ.
Thank
you rock.
you.
Thank you for coming to our show.
Yeah, thank you. We got Trish in Victoria. Trish, what's your question?
Good morning, doctors. I travel around in a camper van, and I've just noticed that a lot of the lakes that I go to lately are drying up, yet there's been a lot of rainfall. So I'm wondering why this is. Why is all the lakes drying up when there's been a lot of rainfall?
Which part of Australia are you in?
I'm in Victoria at the minute at a place called Lakes Rats Castle. I was here a couple of years ago and the place was flooded, and now people are saying that the lake will probably go dry by the end of summer. So yeah, Lake Victoria in the lower parts, like southeast.
Definitely don't know. You'd need a
South
local
Australia.
geographer to tell you what's going on. It could well be that the local councils get their water from that lake for drinking or for irrigation. Don't know. Definitely don't know. I guess if we've got a geographer, please ring in to 0439 757 555.
Yes.
Stand on
Thanks,
beat.
Trish. And Jazz, to wrap us up, Jazz in Sydney, what's your question?
Hi, doctors. I was listening to the Hack podcast last night, and it was such a fascinating story. And it had me thinking, what is it that causes an addictive personality? Would you be able to answer that, doctors?
The easy answer, which is incorrect, is it's due to, and then insert the name of any one of the many thousands of neurotransmitters that exist. And most people only know 2 of them, which are dopamine and serotonin and maybe acetylcholine. And they say it's too much or too little. We do not know. We know it's real. We know it can be due to genetics. It can be due to environment. We still don't know. I'm sorry.
No, that's okay. Thank you so much for your honesty.
Thanks, Jazz.
Thank you.
We can check out that story as well on addiction via the Triple J Hack podcast. And the same with this one, Science with Dr. Karl, wherever you get your podcasts and on Triple J's YouTube channel. Dr. Karl, we'll do this again next week.
Peachy keen. Catch you then.
And that's it. Thanks so much for listening to this episode of Science with Dr. Karl. And remember, you can always ask a question live. Be listening to Triple J on Thursdays, 11 a.m. Australian Eastern Daylight Time. Text in your question on 0439 757 555. In fact, you can do it anytime before then as well, from 9 a.m. Australian Eastern Daylight Time on Thursdays. We'll lock away your question and stay by your phone, because if it's good, we'll get you on air to ask Dr. Karl yourself. This episode was produced by Jazz Williams. I'm Lucy Smith. We'll catch you next week. Bye.
Dave Marchese here from the Triple J Hack team. Hey, if you love Dr. Karl's podcast like I do, you might enjoy the Hack podcast as well. Each day we bring you the news that matters to you, from the latest science on climate change to what's happening in politics and news around the world. The Hack podcast. It's your daily fix of the news you need to know. Get it wherever you're listening now.